Hello, my name is Sergei Silnov, and today we are going to talk about IDF Component Manager, a relatively new addition to the ESP-IDF. It helps you to manage dependencies of your ESP-IDF projects. To begin, let's start with the common structure of CMake ESP-IDF projects. Today we are going to talk only about CMake ESP-IDF projects and not about legacy make-based projects. How typical project organize itself? It consists of the main component. Everything in ESP-IDF project is a component. Even the code of the project itself usually placed to the main component in the root directory. Other components that may be used in your project typically located inside of components directory. However, if you have some other components that you want to share between many projects, you may have them laying somewhere else on your disk and just specify them in CMake list.txt file as extra component dirs, and they will be loaded from this path. Also, ESP-IDF itself contains tons of different components that can be useful for a typical project development. This is nice, however, this situation is not perfect. First of all, it's hard to share components between projects. Of course, as I mentioned, you can specify components in extra components dirs. However, if you want to move your development setup to a different machine, or you work in a bigger team where all the developers need to have the same components, it causing some troubles. It's especially harder if your components are not that simple and have their own dependencies, and their dependencies have their own dependencies. When we have a relatively deep tree of requirements by components, handling all these things becoming really tough. Also, it's provide no means to control version compatibility between components and make sure that you're using correct one. Another plane of problems is if you're an open source developer and you want to share your components with the community. You can share them on GitHub and advertise them on Espressif developer forum, but there is no standard way to find new components, discover new features. And it's also worth mentioning that having all the components that may be used by wide variety of different projects inside IDF causes problems too, because IDF release cycle is relatively long, and if you want to add new features to some particular driver or network library, we have to wait for the next minor or major release of ESP-IDF, because we cannot introduce new features in bug fix releases. So it slows down the addition of new features. Okay, so now it should be relatively clear what kind of problems we have, and luckily we have a solution. Our solution is to design our own registry of components. It's a web service that hosts archives with component files and some information about them, allowing easy discovery and centralized control for components. Also, in addition to this registry, ESP-IDF now includes an IDF Component Manager, a CLI tool that integrates ESP-IDF CMake build system and downloads all the components. IDF Component Manager made in such a way so if you don't know about it, it still may work for you. It may as much magical as possible while keeping it still transparent. Component Manager is made secure by default, and all the components have their cryptographic hash sums stored and checked every time to make sure that your dependencies always the same as they used to be. Technically, IDF Component Manager is a Python package which is delivered with your ESP-IDF setup. It works with all currently supported ESP-IDF versions starting 4.1. However, it was mentioning that it is included by default to IDF 4.4, and older IDF releases only included by default in most recent bug fix versions. Good thing to know that ESP-IDF Component Manager has its own release cycles, so new features are delivered much quicker, and even for older IDF releases, you have all the available stuff every time. Let's try using IDF Component Manager with our own project. Let's go to the registry. It is hosted on http components.espressif.com. Here you can find dozens of hosted components. You have some filters and ability to search them. At the moment, there are a lot of components of different kinds: network protocols, peripheral drivers, and board support packages. Convenient bundle of all the drivers you may need to use all official Espressif development kits. Here we will go with example component, which is named example CMP. Please note how the name looks like. It consists of two parts: namespace, example, and component name itself, CMP. Namespace is something like a username or organization in some other public hosting services, for example, on GitHub. You can find some other useful information on the component page, like a list of all available versions, a license of the component, a list of dependencies, and a README file with detailed information. To add the component to our project, you can either manually create idf_component.yaml file in any component directory of your project. In our case, it may be main IDF component, and add two lines: dependencies and the name of component alongside with version specification. Or you can achieve the same by running command idf.py add dependency and passing the name of component optionally with version specification. You can find this command to copy on component registry page. Quick note about specification formats. You can use a number of different syntaxes to specify version formats. If you do not care about version, you can just put an asterisk, and most recent version of component will be downloaded. You can specify a whole range of versions, comma-separated list of rules. You may exclude some particular versions or set upper or lower limits. However, the recommended way to specify dependencies is to pin the version that you actually need and then a caret symbol in front of it. So the most recent compatible version will be always downloaded. Versions of components in the registry mainly follow semantic version specification. So if you are familiar with semantic versioning, you should understand how versions work in the IDF registry. Okay, now we have a requirement added to our project. Let's run CMake build system. During a run of CMake, Component Manager will be called and all the dependencies will be processed. Here in our example, you may find that Component Manager processes actually two dependencies, example CMP and IDF, even though we only added example CMP to our project. How did it happen? This is because IDF dependency comes from example CMP manifest itself. Here you can see that example CMP depends on IDF and specifies its version bigger or equal than 4.1. It's important to mention that IDF as a dependency is a bit special. It allows to specify version requirement of ESP-IDF. However, Component Manager never installs any versions of IDF itself. It only checks that version you are using right now is compatible with all the components participating in the build. While in our example everything went smooth and we didn't have any issues solving components, Component Manager is smart enough and provides a lot of details when solving of dependencies went wrong. For example, here if we run Component Manager for some components that require a newer IDF version on older IDF release, you will see a detailed explanation which component requires which version and why it cannot be satisfied. We are putting a lot of effort to make these error messages clear and useful, so if you find any error message that is not clear for you, it considered an issue, so feel free to report it. Okay, we have Component Manager run successfully, so let's take a look how the project will look now. There are a few files added to the project directory. First of all, a whole directory of managed components, where our component example CMP was downloaded. Take a note on the name. Even though we added the dependency as example/CMP, in the file system they are stored as example double_CMP / with double underscores. And with this name, components will be visible to the build system. So if you have some build issues from the build system, you may find these names in some cases. Don't be confused. Take a note that managed components directory can be easily recreated, so it is recommended to add it to gitignore file if you store your project code in Git repository. Another file that was added is a dependencies log file, which contains a whole list of dependencies generated by the Component Manager. One more file worth mentioning here is .component_hash file in the managed components directory. It contains hash sum of component as it was downloaded to the managed components directory. Files in this directory are not meant to be editable by user, and if you accidentally or intentionally modify some files, a component manager will complain that files are not in the same state as they used to be before, and will suggest you to either overwrite your changes or move your component to the components directory of your project and continue modifications here. As I mentioned before, dependencies log file contains a list of information about all the dependencies. In our project, we have only 2. Every dependency also has a hash sum and a source where it was downloaded from. Also, this file contains manifest hash sum. It's a hash sum of all manifests of all components in your project. This number is used to make sure that your log file will never be updated once your requirements solved. Only when you add new dependencies or modify versions, Component Manager will run again, but it won't rerun if you just rebuild your project. One more note is about naming. As I mentioned, if you modified some component in a Manage Components directory, Component Manager will suggest you to move this component to Components directory of your project. So it's clever enough to actually find possible candidates for components that you in the requirements file that actually may already be included in your project. So if you have 2 components in your components directory, one is named CMP and one is named example_CMP, it actually won't be sure which one you meant to use if you have a dependency example/CMP or some other in your manifest file. Also, you may not reuse components that are already in IDF. However, we have yet another feature to solve this issue, but we'll talk about it a little bit later. Component Manager also tries to use as little network as possible. So even if you use the same components in many different projects, they won't be downloaded many times. Every component version is downloaded to a system-wide cache for your user. Location of this cache depends on your operating system. But you always can check what files you have there or clean this cache if you want. Also, Component Manager caches API responses for the short time. So solving a lot of dependencies won't load server too much and will be much quicker. Okay. We built our first project with ESP-IDF Component Manager. Let's take a look what other features it provides for you as a user of hosted components. First of all, normally when you're adding some dependency through CMake list.txt files, you have to specify how the component will be required. Will it be private requirement or a transient one? You have the same option with the Component Manager. By default, all components required as private ones. However, you can specify them to be public or set required to false. In this case, component will be only downloaded but not included to the build. It is useful for components that only provide some CLI tools or CMake extensions. You can also specify when a component should be downloaded. It is useful for projects that are built for many different targets or should work with many different IDF versions. For example, it's useful if some component is included in older IDF versions but was removed from IDF itself and moved to the component registry in newer releases. For convenience, you can also use your existing components in different Git repositories. You can specify Git repository URL to download your components without using submodules. This may be simpler because it doesn't require any extra steps to set up your environment on a new machine. Also, if you notice, you can use environment variables in manifest files. This can be useful, for example, if you don't use SSH for authentication of your Git repos and rely on HTTP basic auth. If your Git repo contains more than one component or component is just not in the root of the directory, you can specify the path. It's important to mention, however, that Component Manager doesn't support any out-of-the-tree dependencies in CMake files. So if your component requires something outside of its root directory, it won't work, and you have to find another way. Also, if you're developing your own components that are meant to be shared on the registry, you may find useful to mention them in a test project using relative paths. And Component Manager also supports specifying local directories as sources of components. However, in this presentation, we won't focus on how to upload components to the registry and only how to use ready available components. Okay, so far we already listed a number of features that are available for you right now. However, we are working to make Component Manager as good as it possible. Usually in embedded world, tools not that always as great as for example, in world of web development. We are checking many different systems available these days and trying to involve the best practices in our development. So we are working on a standard way to write documentation for your components, and very soon templates and documentation hosting will be available. You can find documentation in standard way in the component registry, and when you're writing documentation, you will be able to preview it locally. Also, component registry will have a special care about components examples, and you will be able to create a new project out of an example with only one click. If you don't trust a registry hosted somewhere else, you will be able to create your own local mirror with only one command. At the moment, Component Manager is available for everyone for downloading components. However, to upload components, you have to fill form for a private preview. But very soon we'll open sign up for everyone. And we are looking for your contributions. Don't hesitate to share components. Also, IDF Component Manager itself is an open source software and developed on GitHub. You can find source code on Espressif account under IDF Component Manager name. We accept merge requests and issues, so feel free to contribute. Thank you so much. Now it's time for your questions.